the engine that fired its camshaft. For over 100 years, every gasoline engine on Earth depended on one part. Millions of engineers accepted it as unavoidable. Every university taught it, every manufacturer built around it, every mechanic trusted it. Then, one company just threw it away. No camshaft, no timing belt, no compromise. And somehow, the engine ran even better. That shouldn't be possible. So, how did they do that? Today, we are uncovering one of the boldest engineering ideas ever placed inside a combustion engine. There was the rule nobody dared to question. Imagine inventing a machine so successful that for more than a century, almost nobody questions how it works. That's exactly what happened with the internal combustion engine. Since the late 19th century, one component quietly controlled every breath the engine took: the camshaft. It doesn't produce power, it doesn't burn fuel, yet without it, the engine cannot run. Every intake valve, every exhaust valve, every combustion cycle, everything depends on its timing. As the crankshaft rotates, the camshaft rotates with it, using carefully shaped lobes to push each valve open at precisely the right moment. Open too early and fresh air escapes. Open too late and the cylinder cannot fill properly. Mistime it completely and the engine simply stops working. For generations, engineers refined this brilliant mechanical system. It became reliable, efficient, and almost perfect. Which raises an interesting question. If the camshaft already worked so well, why would anyone ever remove it? Here is the hidden problem inside every engine. To understand the answer, we first need to understand something surprisingly human. Think about your own breathing. When you are sleeping, your breaths are slow and gentle. When you are climbing stairs, they become deeper. When you are sprinting, your lungs work as hard as they possibly can. Your breathing constantly adapts to what your body needs. An engine wants to do exactly the same thing. At idle, it only needs a small amount of air. During hard acceleration, it wants as much air as possible. But here is the problem. The camshaft can't adapt freely. It's nothing more than a beautifully machined piece of steel. Once its shape has been manufactured, its valve timing is fixed. No matter whether you are stuck in a city traffic, cruising on the highway, or racing around a circuit, those Camless continue following exactly the same mechanical profile. Engineers knew this limitation decades ago. Instead of removing the camshaft, they tried to make it smarter. Honda developed VTEC, BMW introduced Vanos, Toyota created VVTi, variable valve timing. Other manufacturers experimented with variable valve lift, cam phasing, and increasingly sophisticated mechanisms. Each innovation made engines better, more power, better fuel economy, lower emissions. But they all shared one important limitation. They were still trying to improve a system that had never stopped depending on the camshaft. Eventually, someone asked a completely different question. The question that changed everything. And that someone was a brilliant engineer, Christian von Koenigsegg. Instead of asking, how can we build a better camshaft, he asked, why do we need one at all? Think about that for a moment. The camshaft exists for one purpose: to decide when each valve opens and when it closes. But what if every valve could make those decisions independently? Instead of one rotating shaft controlling 16 valves, what if each valve had its own intelligent actuator? No mechanical link, no compromise. Complete freedom. That single idea became a free valve mechanism. Traditional engines behave like a marching band. Every musician follows the same conductor. Every movement is synchronized. Free valve changed the orchestra completely. Each valve receives its own pneumatic-hydraulic-electric actuator instead of waiting for a rotating cam lobe. The valve receives commands directly from the engine's computer. Every combustion cycle, the software decides exactly when the valve should open, exactly how far, exactly how long. And because every cylinder operates independently, the engine can continuously adapt to changing conditions. No mechanical compromises. Only software making thousands of decisions every second. For the first time, the engine wasn't simply bracing. It was choosing how to brace. So, why this changed everything? Once every valve becomes independent, remarkable possibilities suddenly appear. During gentle cruising, some cylinders can remain inactive, saving fuel. During hard acceleration, the valves can maximize airflow, producing more power. Cold starts become cleaner. Throttle losses are dramatically reduced because airflow can be controlled directly at the valves. Turbochargers respond faster. Fuel economy improves, emissions decrease, performance increases. And instead of forcing every cylinder to behave the same way, each cylinder can do exactly what the engine needs at exactly that right moment. It's no longer mechanical optimization. It's software-defined combustion. If so, then why doesn't every car use it now? So if free valve mechanism offers so many advantages, why hasn't every manufacturer adopted it? Because replacing the camshaft was actually the easy part. Those actuators must survive billions of operating cycles, extreme temperatures, constant vibration, oil contamination, high engine speeds, year after year. Then comes manufacturing, reliability testing, cost, certification, and mass production. Engineering history is filled with brilliant ideas that were technically superior but economically impossible. Sometimes inventing the future is easier than building millions of them. Therefore, for more than a century, the camshaft quietly controlled how engines breathed. It became one of the most successful mechanical inventions in automotive history. Then, Koenigsegg asked a question almost nobody else dared to ask. Not how do we improve it, but do we still need that? Whether free valve becomes the future of combustion engines or remains one of engineering's boldest experiments, it reminds us of something every engineer should remember. Innovation doesn't always begin with better answer. Sometimes it begins with the courage to question a rule that everyone else accepted. If you enjoyed uncovering the engineering behind the free valve mechanism, subscribe to Engineering Uncovered, because great engineering isn't just built, it's uncovered.